The mystic rectangle. Ataria lives on a toroidal map known as the mystic rectangle, where opposite edges of the map are connected. Crossing an edge teleports her to the opposite side. Ataria can move in any of the four cardinal directions or along the four diagonals of 45 degrees. Given Ataria's coordinates and the coordinates of the goal, find the fastest time for her to reach the goal, assuming no obstacles. Moving east or west, plus 1 unit in x takes 0.3 seconds. Moving north or south, plus 1 unit in y takes 0.4 seconds. It takes 0.5 seconds to move diagonally, 1 unit either east or west, plus 1 either north and south. After traveling for 1 minute in any single cardinal direction, that is 200 units east, west, or 150 units north or south, she ends up returning to the same place. Example: suppose Ataria starts near the top of the map and travels diagonally 15 units northeast and then straight 5 units due north. In doing so, she wraps around to the bottom of the map, arriving at the goal. Then at 9.5 seconds, this direct route makes the best time of the goal. I'm not going to use C++ for this puzzle. I'm going to use, let's use JavaScript. So for input, the first line, I'm presuming it's this one, is 2 spaces separated integers x and y for the current position. And for the second line, which is this, is 2 space separated integers u and v for the location of the goal. And for output is the decimal time to the goal in seconds with precision of tenths. Constraints: 0 less than equal to x, u is less than 200. 0 less than equal y, v is less than 150. So, for example, it is if 50, 15, 65, 145, the output would be 9.5 seconds. There's 12 test cases for this puzzle. So the first one is example in description. Second one is, well, let me say that again, example in description. The second one is horizontal. The third one is vertical. Fourth one is diagonal. The fifth one is position. The sixth one is skew long. The seventh one is skew tall. The eighth one is east-west wrapper. The ninth one is double wrapped. 10th one is travel on boundary. The 11th one is polar opposites. And lastly, the 12th one is random. Okay, let's solve it.